Can you hear me? I'm delighted to be here, and thank you very much for the invitation, and hello everybody at home as well. So my name is Paola Sakai, and I am a lecturer in sustainability, economics, and policy, and I come from the University of Leeds. As Gareth said, I'm going to present the Food for Our Own Good project. So this project is about food and geothermal energy from mine water. And it departs from the idea that we face multiple challenges. So on the one hand, our environmental impact is huge. The food system is responsible for 1/3 of the world's CO2 emissions. And on the other hand, we are more vulnerable than we realize. 70% of world's food production depends on rainfall. So changes in precipitation patterns and temperature fluctuations associated with climate variability and climate change can disturb massively our food systems. Now imagine if we are net importers of food, like in the UK and many cities in the UK where we import 50% of the food we consume. Furthermore, despite we are producing more food than ever before, we are not fulfilling our nutrition needs. We have high obesity rates, we have diabetes, malnutrition, etc. So we have a problem. So we have multiple agendas to tackle. We need to work together and think outside of the box. So I created a public-private research and innovation partnership and the Food for Our Own Wood project to explore geothermal energy from unused coal mines for food production in vertical farms and greenhouses. It explored ways to get this nutritious produce to hospitals, care homes, schools, and food banks and create a circular business ecosystem that fuels a kind food system. And we are exploring these business models to make this happen. So we can see here how the project speaks to several agendas and have several benefits, which we'll look at the moment. Apologies for the diagram. We need to update it, as many of you have noticed. So, but I want to tell you about what research we have been undertaking so far. So we conducted a stakeholder mapping exercise to locate key stakeholders. We conducted a literature review on the barriers and opportunities of this idea. We then contrasted the findings of the literature review with 52 semi-structured interviews with different stakeholders from the groups that you can see in that box. We transcribed, coded, and analyzed the interviews with NVivo, and then we performed quantitative research on the geothermal potential using geothermal energy and multi-criteria decision analysis. Then a reaction workshop helped us, and again with stakeholders from the industry, local, regional, national government, civil society, and academia, help us to prioritize the most important barriers to tackle and find pathways for action. So now I'll give you a quick brush of some of the findings. So here are some of the benefits that we have found. And so this project has environmental benefits. So for instance, we reduce food miles because we localize food production. And there is a reduction of water consumption by 95% with vertical farms. There are also social benefits such as empower local communities, increase food security, something that with previous presentation we are connecting to our heritage. We also have economic benefits because we revitalize infrastructure that otherwise is a liability, as Niall mentioned yesterday. Also, producing vegetables in a controlled environment can reduce the cost of growing by 50%. And we have political benefits because also it enables a just energy transition. And at the end, I will give you a link to our website so you can see with more detail these boxes. And all that sounds wonderful, right? But however, there are many, many buts. So, and here are the barriers that we have identified in my research. And actually, we discussed some of the barriers yesterday. Like, for example, we have economic barriers. We have high start-up costs, not only underground, but also above ground. We have political barriers, such as pressures for land to build houses instead of greenhouses. Regulatory challenges as well, that for instance, we talked about this plenty yesterday, but for instance, that the lack of a governing body like that we have with oil and industry, with oil and gas, we don't have that in the UK. We have environmental barriers such as heating pockets of methane that could exacerbate climate change. There are social barriers like lack of skilled labor or social acceptance, for example. And finally, we have technological barriers as well. And all the boxes shown in this slide are the themes and examples of the technological barriers and we talked about this yesterday, and I'm putting them here because, you are the experts. So if you know about this, please get in touch. So our case study at the moment is in the city of Leeds. So here we can see the areas with greatest potential. So with coal authority data, we can see here the underground workings, so which are mainly located in the south. The dots are the mine entries, and this graph on the left shows the temperature estimates. On the right, you can see a mine water geothermal potential index that combines two measures of geothermal energy potential, and this comes from modeling done by one of our master students, Alex Connolly, and Ben Carver, a research assistant, and they calculated total of and usefulness of mine seam volumes, and that, I'm not a geologist, but I can refer to them in later. But you can see that geographically in Leeds, that is where the potential exists. But in addition to explore the geothermal potential, this project aims to enable a circular economy with climate-resilient infrastructure. And according to the latest scientific report of the IPCC, the greatest potential to increase climate-resilient development lies in those areas where there is high vulnerability. So with more than 50 data sets, I characterize the climate vulnerability of the 416 LSOAs of Leeds. And you can see here the areas of the cities with higher climate vulnerability. Those are located in the center, and these are red in color. And so, but what does it mean? So it means that in the center, there is a higher propensity of the population of Leeds to be adversely affected by flooding, heat waves, and pollution risks. So I took a health-led approach. On the right hand, we located the points of interest. So we located the food banks, the schools, the hospitals, the community projects, the care homes, and we superimposed those with LSOAs with the highest climate vulnerability and population density. So then we undertook a multi-criteria decision analysis using our stakeholders, so we asked our stakeholders which were the factors that were more important to identify the best location, and what importance they would give to each of those factors. So, of course, the most important factor is to have geothermal, to have geothermal potential, to have not only the potential, to have the geothermal energy, the distance to the points of interest, the climate vulnerability of the site, that is a brownfield site that is outside of green belt. And this map shows the average of the MCDA results, so the multi-criteria decision analysis results. And we produced a policy brief. So with our stakeholders, we had a seven-point plan of action where we can take this project forward. So yesterday as well, we were talking about the vision, right? The vision about several barriers. So this is the vision of the project. And the vision of the project is that, we have the partnership, and this partnership is creating a proof of concept for pilot projects and living labs that explore above ground and below ground technologies that create efficiencies, generate IPs, and shape our cities with food that is good for people and for the planet. So thank you very much. This is the link where you can find of the website, and I come representing the Global Food and Environment Institute and GeoSolutions Leeds. Thank you very much. Get in touch if you want to be part of this idea or you want to collaborate. Thank you very much.